J'ai passé devant ta porte, j'ai crié papa à l'entrée. Y'a personne qui m'a répondu. Oh yeah, mon cœur fait mal.
Welcome to South Louisiana and the Barataria-Terrebonne National Estuary. We're going to tell you some stories today. Stories of the birth of this beautiful estuary, stories of the people who live here, stories of the plants and animals who also call this place home. Joining me today is Carrie St. Pé, Director of the Barataria-Terrebonne National Estuary Program, who is a descendant of Jean Lafitte, the pirate. In order to understand where we are, let's look at this image taken from space. From space, you're going to see Florida way over here off the map, Texas on this side, but take a look at this beautiful structure down here. This is the Mississippi River Delta. The story of how this delta was formed is a wonderful story. And in order to understand that, you need to take a look at the Mississippi River watershed. A watershed is a place where a drop of water falling at the top of the watershed ends up at the bottom. We are at the bottom of this enormous watershed. All of these are streams that flow into the Mississippi River, and all of these streams are carrying soil, sediment, mud. When this soil gets down to South Louisiana, it empties into the Gulf of Mexico, building a delta. And in the springtime, when the ice and snow melts in the north, water comes pouring down these rivers, down these waterways, down into the Mississippi River, and the river used to overflow her banks, spilling this rich load of soil and mud and building land. We call this the reunited states because we may be well standing on parts of Kansas and Nebraska, recycled soil. This truly is America's wetland. Let's take a look at where we are now. On this map of the Barataria-Terrebonne estuary, we have the Mississippi River on our eastern border and the Atchafalaya on the western. Flowing down the middle is Bayou Lafourche. We're broadcasting now from the Golden Meadow Hurricane Protection Levee. Later, we'll be traveling to Elmer's Island right on the coast. In order to understand how unique this area is, take a look at the map of the watersheds for all of the National Estuary programs. You can see how large the Barataria-Terrebonne watershed is in comparison. Carrie, can you tell us what it is that makes this area so productive?
Well, as we saw from the watershed map that you show, we are at the bottom of one of the world's largest rivers, the Mississippi River. And when that river meets the ocean, meets the Gulf of Mexico, wonderful things happen. We create an estuary, a place where fresh water from the rivers mixes with the salt water from the oceans. They're very, very productive systems, the most productive ecosystem in the world. And we have so much wetlands because we have such a big river that feeds into our system. So we have the habitat, the home for all these animals and fisheries and crabs. We have plenty of place for them to live. So, of course, then we are very, very productive because of this big, big river and this huge estuary.
Something happened in 1927 to change all of the story that I told you about the river overflowing its banks. Something happened then, decisions were made that affect us today very strongly, both the benefits of those decisions and the tragedy of those decisions. Carrie, what happened in 1927?
Well, in 1927, the United States experienced probably the single largest disaster of its history, the 1927 flood. The Mississippi River flooded its banks, and much of that watershed on that picture that you showed earlier was flooded, and people were flooded out of their homes. People lived on the levees for months, and so people said, you know, demanded that we be protected from flooding, and so the levees were created, and we put the Mississippi River in a channel, kept it from overflowing, and we no longer are providing sediments for these wetlands. And so consequently, we are disappearing now. We are the single most, well, we're critically disappearing. We're the fastest disappearing landmass in the world. We are losing our wetlands at the rate of 22 square miles per year, which is causing us some very, very serious problems.
Okay, thank you. I'd like to introduce you now to one of South Louisiana's most unique and ancient creatures, the American alligator, a creature who was also in danger of disappearing at one time. Thankfully, this story has a happier ending. Joining me now is Mr. Mitch Samaha from the Louisiana Department of Wildlife and Fisheries.
Hey, Deborah, how you
Morning,
doing?
Mitch.
Good morning.
Tell us about who's in your pocket here.
Well, this little guy right here is the American alligator, and he has an interesting story behind him because he was almost hunted and trapped to the point of extinction, but thanks to some biological research that was done by the department, he is now alive and well in the Louisiana marshes, and it also provides a valuable resource for the Louisiana economy. When they come out of the eggs, they're approximately 10 to 12 inches long, and they grow at a rate of anywhere from 2 to 12 inches per year, and of course that's dependent upon temperature and the diet that they receive. The farming practices that we have now in place can actually control the temperature and the nutrition, and they can actually grow these alligators twice the rate of an alligator in the wild, which makes them marketable by the time that they're 3 years old.
Okay.
And this is a typical little alligator right here. He's about a month old, and he's a little nervous, but he's just fine. The mother of this species is as formidable and as aggressive as we think they might be. They're actually very good mothers. They protect their nests very aggressively, very aggressively. And this is a typical alligator coloration that we see here, brown. And they absorb the sunlight very well, and you can see the camouflage pattern on him, which hides him from predators at such a young age. On the other side of the spectrum, we have the white alligator, or this is an albino, a true albino. And the difference between the albino alligator and the albino is
going to tell us that.
The white alligator and the albino alligator are different because the white alligator has blue eyes, and as you can see, the albino alligator has pink eyes.
Very interesting. I have never seen an alligator with pink eyes before. Have you?
No.
This is my first.
And Alyssa, why would a white alligator not live to be this size in the wild? Look at this one. Does this one, you think this one blends in a little bit better?
Yes.
Than this one? Absolutely. Yes. That is correct.
Protecting the alligators that live in not only the wild but the alligator farms near here, is this levee that we're standing on. The guy who has the important job of taking care of this levee is Mr. Wendell Curall, the South Lafourche Levee District. Wendell.
Deborah. Yeah, how you doing this morning?
Comment ça va? Fine. Bien.
Bien, ça va bien. Yeah, again, our people here, we've had our people been living in South Louisiana now for a couple of hundred years since the Louisiana Purchase, which is the bicentennial this year. And through the years, we've had to move along and actually migrate. Our people basically settled in New Orleans and then, of course, came to the coast. We have one of the most productive coastlines in the United States. And because of that productivity, the fishing has been tremendous. The oysters, the fish, the shrimp have been fantastic. But we've had hurricanes and other problems. And those hurricanes have caused us to kind of move back. But along with that, we've had this land loss problem, which is also attacking the communities. And these are all problems that we have. Now, we talked about the levee system, but if you look at the levee system, on one side of the levee, now we're 23 miles from the Gulf of Mexico. The water on the outside of the system at a plus 2 foot elevation, the salinity is around 10 parts per thousand. The water on the inside of the levee system is at a minus 5 foot elevation and has 0 parts per thousand. So it's not at all salty. It is very fresh, and the outside is very saline.
So this levee is very important in maintaining that salinity difference between the outside and the inside.
Yeah, but again, talking about the problems that we had, again, the communities were on the coastline in Louisiana. We had one of the largest communities on the Louisiana coast, Camanada, had 1,700 people. Now, back in 1893, that was a lot of people. A hurricane hit and killed half the population. The survivors of that storm moved to Leeville and then to Golden Meadow in this area. Okay, Leeville is about 12 miles from the coast. 7 out of my 8 great-grandparents lived at Camanada on the Louisiana coast. 3 out of 4 of my grandparents lived in Leeville, 12 miles from the coast. My parents, my mother was born here in Golden Meadow, 23 miles from the coast. My father, 35 miles from the coast. And now I'm raising my children 40 miles from the coast. And what's happened to my family is what's happened to the communities here in coastal Louisiana because of this land loss issue. We've come further and further up. Now, years ago, we didn't need this levee. 100 years ago, the marshes between the Gulf of Mexico and here, the marshes in the Berry Islands protected us. We didn't need hurricane protection. That's why our people moved here. But because of the land loss issue, the Gulf of Mexico has basically gotten 20 to 30 miles closer to everyone who lives in South Louisiana. And that's why we had to build this hurricane protection system in this place.
And the closer the Gulf gets to us, the higher the storm surge during hurricanes and even minor storms, as we're finding.
That's exactly right. Years ago, you know, it took a very powerful hurricane to put water anywhere near this area. Well, in a 9-month period, over the last year and a half, in a 9-month period, we had 2 tropical storms and a hurricane that didn't hit this area. And those tropical storms pushed a 6-foot wall of water, 7-foot, and 7.2. Those 3 storms would have flooded this area had it not been for this levee system. And years ago, 100 years ago, we didn't even need this levee system. That water would never have reached this far inland. And that's really the problem for our communities where we live. We live in a very special area. We're here because we are, you know, the other places are on the beach because they're tourist centers. This place produces for the country. We produce seafood. 30% of the nation's seafood produced by wetlands is produced here in Louisiana. When you look at oil production, the infrastructure that produces 30% of the nation's infrastructure for oil and gas keeps that price of gasoline lower than it would be today. This place protects that. That's 30% of the nation's. We have the only deep offshore oil port off of this place. 16% of all the foreign oil that comes into the United States comes through this area. And with the land laws that we have, it affects not just the people in Louisiana, but if you live in Iowa, the price of your fuel, if you're a farmer, the price of your fertilizer, and the price of your chicken even, because the chicken feed is made from fish that are produced in the marshes of Louisiana, Menhaden. So all of these things make this place very important to the rest of the nation. But we have a very unique culture. I grew up in a community that all the adults spoke French. 7 generations here. I'm the first generation to speak English before I spoke French. And that's because this area is so productive that we pretty much could live our life the way we wanted without too much interference.
So Wendell, tell me how this levee protects us. What happens, for instance, if rain falls inside the levee? Doesn't that present a problem with flooding?
Exactly. See, the normal situation, the water, of course, would just drain off from the highland, and that's another unique thing about South Louisiana. Our highland is near the waterway. It's near the bayou. And the water would just drain off. But when you have to build a levee system to protect from hurricane flooding, that means you've basically developed a bowl. So any water that falls in, any rainfall that falls in, has to be pumped out. And we have pump stations. We have 6 pump stations that can move about 1.2 million gallons per minute.
Wow.
Well, we have a lot of rainfall. Our average rainfall in Louisiana is about 60 inches a year.
60.
So that's a lot of rainfall. But yeah, that rainfall has kept, when we have a regular rainfall year, we keep the marshes a little bit fresher. We had a drought situation for a couple of years. The water intake for our drinking water is 45 miles from the Gulf. And with that drought, people started drinking salt water. You could taste it. And it was unhealthy. It was not drinkable water because of that problem. And years ago, we never had that problem. Our saltwater line was only a couple of miles from the Gulf. Now that saltwater line came in 45 miles and threatened our drinking water. Luckily, we started getting more rainfall, and we're taking some action right now to stop that salt from coming in. But we need to take bigger and stronger actions to do that.
As you can see, this is a very complicated issue, this land loss problem, and it requires complicated solutions. It's a very big problem, and it requires very big solutions. And all of those solutions seem to involve bringing the river back in, The river is what built this land, and it's the river that will help to rebuild it. But these projects take lots of time and lots of money. We have no time to lose. We'd like to take you now to Elmer's Island, where you'll see something that citizens are getting involved in. Citizens are recycling their Christmas trees. Citizens are involved in marsh planting. And we're going to go to Elmer's Island in just a minute and check out what kids like you are doing in the Montague Middle School. Before we do that, though, we want to address some questions. We hear that we have some questions.
Actually, Deborah, we seem to be having a lot of questions coming in, and we're thankful for that. But we're going to have a series of questions here regarding alligators, and so we're going to have to bring Mr. Mitch Samaha back from Wildlife and Fisheries. Mitch, one question here from Mrs. Tello's science class, Edwards Middle School. Difference between an alligator and a crocodile?
Well, that's a common question, and what it is the crocodiles, are average. They're much larger than the typical alligator. An alligator will average in the wild anywhere from 10 to 12 feet. Some of them get larger than that, where a crocodile will actually reach 20 feet. Alligators, the skins are much more preferred on an alligator for their durability, and the difference is that on each scale of a crocodile you have a pore, and the snout on a crocodile is much longer, whereas on an alligator they're broader, and a crocodile also has many more teeth that are actually exposed.
Okay, we have another question here from the Hull Diaceta Junior High, and I expected this question, Mitch.
Okay.
Why is it so easy to keep an alligator's mouth shut?
Well, because all of its force is in the muscles that allow the jaw to close. They can close, an adult alligator can close with 3,000 pounds per square inch of pressure, but the muscles that open up the alligator's mouth aren't as strong, and you can actually hold them together with 2 fingers.
So you wouldn't want to hold that alligator without that tape?
That is correct.
I don't blame you.
We do have some tape around this gator's
We do have
mouth.
tape around the gator's mouth.
Right. Now, here's a question from Monroe School, I think 5th grade class. I'm not sure if that's the name.
Okay.
But it's a school in Monroe. Why are alligators so scary, Mitch?
Well, scary's in the eye of the beholder, and alligators, I guess the movie and the movie industry and Hollywood has created an effect that the alligator is a man-eater, and he is something to be feared. And that's not necessarily the case. More so, he needs to be respected, because an alligator that is protecting its nest is a formidable opponent.
Great. Any more questions?
Well, we got a lot. Now we're going to try to address some of these as they come in. Mrs. Nichols' Honor Science class at DeRitter Junior High, 8th grade class. The question is, we understand that the Barataria-Terrebonne estuary is in danger. What is being done to save it? And of course, we are in danger from our land loss issue as well as our water quality issues. And we're actually going to talk about this a little bit more later, but there's partnerships. It takes a lot of people. And we have people like Mr. Curall who are protecting us. And he's also working on places and things to address these issues. But simply put, we need to return to the Mississippi River. We need to use the Mississippi River to replenish the sediments that we're losing in our system. And we have another question here, and this was going to go to Mr. Wendell Curall. How does a hurricane affect an estuary, Wendell?
Okay, good question. Hurricanes, we have land loss. We talked about the tremendous amount of land loss that we have. We see these barrier islands used to be solid before. These marshes used to be solid. When I was a kid, it was solid all the way through here, tremendous protection. But now with the land loss issue, when we have a hurricane, there's so much more exposed marsh that actually chunks of marsh get taken out. So that just the force, just the energy that hits the coastline eats up a lot of the coast. Also, because we've lost the coast, the hurricane surge is coming closer and closer to us. Even in the Lake Pontchartrain area, people on the North Shore who never flooded before are starting to flood because the marshes here have gone away. But also it changes the regime of the estuary. An estuary works out well because it has fresh water in the north end and it tapers to salt water on the south end. When you have a hurricane storm surge, it can push very salt water far inland and stresses the animals and the plants. So it has a lot of effect naturally, and it affects the places that we live and we work. So Carrie, next question.
Okay, questions just keep coming in. Great.
Last one.
Last question from Mrs. Sabatini's homeroom class, Carroll Elementary. And We work with this teacher quite a bit. This is going to be a question for Dr. Earl. What species of fish are in the estuary, Earl? Can you tell us that?
Well, I'm glad you gave me such an easy question, Kerry.
I know. I picked that one.
Hundreds of fish live in the estuary. I think when you look at the estuary, you need to understand that you have many fish that live here all the time. And then you have many fish that live in fresh water but visit the estuary for a short period of time, and many ocean fish in the Gulf of Mexico that do the same thing. So the number of fish will vary on season and species, but 100 fish, hundreds of fish is an easy number. But think of an estuary as a place where you have not only fish that stay there all the time, but you have a lot of visitors too.
Thank you, Dr. Earl.
Thanks.
And now we're going to cut over to some footage that we have from Elmer's Island on a trip that we took earlier. And after that Elmer's Island trip, there will be an opportunity for more questions. We love the questions that you're bringing in. Keep them coming. And we're going to be now joining David Bourgeois with LSU Ag Center as he talks about the Coastal Roots program. Even school children are getting into the coastal restoration movement. David Bourgeois, can you tell us a little bit about what these children are doing back here?
Well, much more than planting these plants, these black mangroves that they brought, they're growing these plants from seeds at their school, about 1,000 of them at 15 schools across the state. And when they harvest their crop, they're coming out here to actually plant what they grew.
So they actually get the full experience of planting them, growing them, and coming out here and being able to do something for coastal restoration.
Absolutely. This is an excellent project for them. They love working on it, and the benefit is to take them out on a field trip like this. They love doing this.
We're here at a back canal. This is fresh water, but it has also salt water coming in from the Gulf periodically, so we should find some brackish water. Gary LaFleur, can you tell us why that's important in the estuary?
Well, lower salinity water to me is what's characteristic of an estuary. You got certain types of animals that live in high salinities, and those would be more pelagic animals. But what we find here in an estuary are just the few animals that really do well in something like half seawater salinity, something like 10 to 15 to 25. And not only that, but then it's a special group of animals that can, they're not sensitive to big fluctuations in salinity. So in deep seawater, it's always really high salinity, 35 parts per thousand. But here you can go within an hour from 5 parts per thousand if a big wave comes in to maybe all the way up to 20 parts per thousand. And then when a big rain comes, you go all the way back down to 5 parts per thousand. So it's what's characteristic of an area like this is only these animals that can tolerate big salinity fluxes.
Let's take a salinity reading.
Okay, we have two different types of instruments here. We have maybe the more traditional, and that's this refractometer. So it measures the refractive index of water. And these are, although they're more traditional, they're still pretty expensive, so you always have to be careful with them. And by reading the meniscus, by looking into this instrument, I read something like about 17, maybe 18 parts per thousand. And then Kerry's looking at he's using a YSI salinometer. And
this is an electronic method, and actually it's measuring the conductance, and it transfers that into salinity. And looks like I'm getting a reading pretty close to what you got, Dr. LaFleur, 17.5 parts per thousand.
The thing that's really different about Louisiana's estuary is how far our intermediate brackish waters go compared to other marsh systems. We have this great, huge expanse of low salinity water.
Right.
Whereas a lot of coasts just go from fresh water to
There's a very
ocean water.
Very steep gradient in these other estuaries. That's one of the reasons we're so productive, is because of the vast size of our estuary. Absolutely.
So we got something important here. We got fish for the big fish to eat, but then we also have some fish that are young.
Perch.
Of fish that are going to be a fish that we eat. You know what this guy is?
Sunfish.
This is the Atlantic croaker.
Now the blue crab is Calanectes sapidus, and that means beautiful, savory swimmer. Savory meaning they taste pretty good. Mr. Murray Gaspard is with us today, and Murray has caught a whole bucket full of crabs. Murray, can you tell us how you caught these guys?
That's fine. We caught this with a crab cage that we have over here on the end. This is the male crab, the blue crab. And we have a few other ones. And we have also a couple of stone crabs. If I can catch them without them catching me. Oh, he's got the other one.
So this is a crab cage, Murray?
Yes, sir. This is the crab cage. This is what they do. They crawl up into these funnels.
Okay, I see.
See if I can get one free. Watch, let's set it. They just pass in like that. They climb in.
Okay, and why do they go in there?
They go in there for the bait that's in the middle.
Okay.
And once they get in that funnel, they can't get out.
All right,
so
now,
that's how we catch them.
So we can, this is how you bait it right
yes,
here,
sir.
Murray?
You just open that and put your bait up in there.
What kind of bait you use in there?
We use all trash fish, catfish, whatever fish we have. You could buy pokey fish that's made for bait fish that we use. And all sorts of bait.
Okay, and I noticed these little rings right here. What's that for?
Yeah, that's for the small crabs and fish to get out. So just the crabs stay in there.
Okay, I see. So, of course, if they're real small, they can get out of here.
Right,
but,
yes, sir. And they could really get out if they're too small.
And then you have this float, and that kind of floats on the water, and that's how you know where they are.
That's how you find them. You go after your carp. You just raise it up, empty it out.
What you call it?
This is a female crab. We call it a pom-pom crab. This is where she hatches her eggs in here, and they grow. And then she, after they get big enough, they just leave and take off and make their life. This is a, we call it pom-pom crab, what y'all call it.
Pom-pom crab?
Yeah, it's a female.
That's the French term. It's a crab in the berry stage.
Right.
And you're going to find these down here. Now, further up in our system, you'll find female crabs, but you'll never see a berry crab or a pom-pom crab up in the fresher area because they need the salt water.
Right.
They actually come down here to release their eggs.
Right.
Now, Murray, you're also a shrimper.
Yes, ma'am.
Can you tell me a little bit about your life as a shrimper?
Yeah, we shrimp in the springtime and the summer, but in the winter time we do crabbing and fishing. So it's pretty good.
So your whole life depends on the resources that we have here.
Right, yeah, and they have a lot of erosion, and these stuff needs to be taken care of because we're losing all our wetlands, and that's bad for everything. All the shrimp, fish, crab, and it's not good.
Absolutely.
Yeah, so.
What size shrimp boat you have, Murray? You got a pretty big shrimp boat?
Yeah, I have a 57-foot shrimp boat.
That's a good size. Now,
sir.
Now those types of shrimp boats, that size, those are usually used out in the Gulf.
Right, inshore and offshore, we work the coast.
Right.
Now, white shrimp, brown shrimp, and sea bob in the wintertime.
Now, the inshore people, that commercial shrimp, they're not using boats the size you have, right?
Yes, they are. They're ranging from little bitty Joe boats to 60, 70-foot boats now inside. Right. But you have bigger boats now inside than offshore because it's so broken up and the bays are getting deeper and bigger. Okay. So the big boats are moving in.
Okay.
And they have all sorts of boats, inshore and offshore.
Now we use several different types of nets and collecting gear. We use a cast net, and we use a seine. Now you use your own net, and you use a trawl. What size trawl do you use?
We use 2 25-foot shrimp trawls.
You use two. You use double
inside,
trawls.
yeah, inside waters.
And those are called double riggers.
Yes, sir, double rig, right. And also they use skimmers. Okay. That's 2 nets too. That's like wing nets or skimmers they call it. They fish the top and the bottom.
Yeah. And of course, a trawl is a boat. It's kept open with they call doors or boards, right. Trawl boards, and it has a lead line that keeps the bottom down and a float line up, and it's just a big open net that you drag through the water.
Right. Exactly.
It can be very, very effective.
Right. It could work good.
Sometimes though it's not so effective.
Right. Sometimes not too good. Yeah.
Let's take a look at this bucket of crabs you have, Murray. You have not only blue crabs, but also, see a stone crab in there.
There's a stone crab. And we even have some, they don't want to come out, they're hiding.
Hermit crabs.
Hermit crabs, yeah.
Now, Murray, the stone crabs, you can still keep one claw, is that right?
Right, you can keep the large pinch.
Oh, okay.
And then you release them back and the pinch will grow back.
Right, okay. So by law, you have to leave the smaller
one,
claw.
right.
Okay.
The blue crab is the mascot for the estuary program, and we call her Claudette with her red nail polish. David, can you tell us about the importance of Claudette and her friends to us here in Louisiana as well as the nation?
Well, our local economy has a lot of natural resources and fisheries based to it. In fact, the two local parishes, Terrebonne and Lafourche, where I work, it's worth roughly $500 million to our tax base per year, annually. And in addition, roughly $500 million per year on recreational fishing. So it's a large percentage, and if we lose a lot of this estuary from erosion in any source, we'll be losing a lot of that tax base.
So tell me what we have here. We have crabs, we have shrimp.
Shrimp, crabs, finfish, crawfish, oysters. People come here just to see the birds and see the wildlife and be out in the open here. So just from the nature study aspect of it, that's even worth lots for our tourism dollars. Now, Dr. LaFleur here has some samples that the kids are handling right now of crawfish, which are not found here, but farther up in the estuary in the fresher areas.
You know, crustaceans are a big part of our life here in Louisiana, and what a lot of people know about are this crustacean here. This is the crawfish. We don't find it much in the estuary, but it's up estuary, and so it's connected to the bottom of the estuary. It lives in the water that's flowing down into the salt water to make what we call an estuary. And so we eat a lot of these guys. And then another decapod crustacean that's a big part of a healthy estuary is what we got here. So come a little closer. We got a crab there, and a crab here. These are all fiddler crabs, but in Louisiana, we have kind of a special closeness to the animals in the estuary, and one of the ways that we show that is by giving them special names. So what do y'all call these little guys? You don't call them fiddler crabs. Tululus. So everybody in Louisiana on the coast here thinks of these as tululus. This is Eucheminax, Euchalongus and a girl Euchalongus signalis. So only the boys have a big claw. But one of the things that I like about the tululus is that just in the same way that the marsh is sort of oftentimes forgotten as being an important part of an ecosystem, the tululus are often forgotten as to how important they are to the marsh. And what they sort of act like the earthworms do on the terrestrial part of the mainland. The tululus kind of cultivate a Spartina marsh. So we have behind us a big Spartina marsh. Well, who planted that Spartina marsh? Well, nobody planted it, but who's kind of looking after it? And that's the tululus here. They pick up the sand and the mud and they aerate it and they eat from it and they make little mounds with it, and they keep the marsh that the Spartina lives in, they keep that aerated. And the other thing that's special about these is their eye stalks. They've become a very important biomedical model. People use their eye stalks to do endocrine experiments, and some of the greatest work from that was done right here in Louisiana by Milton Fingerman at Tulane University. So they're important from a research perspective as well as an ecological perspective. That's the tululu. Then I have another, almost like a tululu that people hardly ever see. This is a dead one, it's been preserved, but this is the great land crab. Hardly anybody's ever seen this giant tululu. Have you all ever seen it? It's very secretive. It burrows up underneath the trees and up underneath the mangroves, and every now and then it comes out. It looks like a giant tululu. It's called Cortisoma. It's the great land crab.
It looks kind of like a stone crab.
Yeah, it kind of does. It's one of the most secret crabs of Louisiana. People hardly ever see it. But at some times of the year, they come out to lay their eggs into the water. And so every now and then you find great land crabs coming across the road, and they become roadkill, and that's when people bring them into us. But they also have these great big eye stalks here, and this is one of their important endocrine organs. It's the same, similar to the eye stalk that you can see on this crab here, the same eye stalk that you can see here. And so these are sort of important from a comparative point of view as well as from a physiological point of view. Okay, so this is something else that we find here in the estuary. And just like fiddler crabs, you have to look hard for these. These are Guckinsia demissa, and they're all at the bottom of Spartina leaves, Spartina roots. So this is the ribbed mussel. And it's just another one of those important physiology models that also are an important ecological component of the estuary. These have sort of a symbiotic relationship with Spartina, as well as the euca crabs. And you can teach students about how species in the estuary are interrelated and depend on each other. This is a nice model for that. It's not just Spartina out there. It's Spartina with Gukinsia demissa, the ribbed mussel at the base of its roots, and it's also Spartina that's surrounded by fiddler crabs like this that are living underneath the Spartina canopy, and so it gives them an appreciation for the interrelatedness of species in the estuary.
Here we are at Louisiana's beautiful Gulf Coast. Many of the organisms that live here depend not only on the Gulf of Mexico, but the interior marshes as well. Shrimp are an example of that, and also blue crabs. We have some shrimp here for you today. David and Carrie, would you tell us about the life cycle of the shrimp?
Well, the shrimp starts off as a breeding adult in the open waters of the Gulf. They breed, they lay their eggs, they hatch out, and these larval forms of the shrimp are floating on the tides where they float into the estuary to eventually grow.
Very, very similar to a system like we have right here. Is that right, David?
That's correct.
This is a pretty incredible journey that these things take. I mean, because as much as we like them, fish like them. And so they lay millions of eggs in order for them to carry out their mission of reproducing their species. And so they need these estuaries to protect themselves. And they come in here as post-larva, meaning after the larval stage, but not quite adults. And they depend on these systems and the grasses up in our estuaries to guard and to be protected from predators. Now these post-larvae will get way up. I mean, we even see them almost in salinities that are approaching fresh water. But in the intermediate and freshwater systems, even those parts of our estuary are real important to these brown shrimp.
Now we're ready to find out whether there is a salinity difference from the back canal and the ocean itself. What'd you get, Dr. LaFleur?
In the back, earlier today we had 17 parts per thousand. On the front of the beach, it's about 27 parts per thousand, so that's quite a difference.
Quite a difference, thank you. Barataria-Terrebonne is very important habitat to lots of different kinds of birds that either spend all or part of their lives here. Elmer's Island and other barrier islands are particularly important. David Muth with the Jean Lafitte National Park and Preserve is here with us to tell us about birds. David.
Well, as you said, the Barataria-Terrebonne, just for the same reasons that it produces all of the seafood, all of the creatures that we've been talking about, those in turn feed a wide variety of birds. And because the estuary is at the crossroads between the Gulf of Mexico and the interior of the continent of North America, it's also a very important place as a stopover habitat for birds that are going to and from North America to the tropics, either to the Caribbean, Central America, or even as far as South America. Birds that fly across or around the Gulf of Mexico. So the estuary provides food for a wide variety of breeding birds. It provides wintering habitat for millions of birds from farther north that breed in the northern United States and Canada, ducks and geese, and it provides, as I said, this stopover habitat. In fact, behind us on the beach are a flock of black terns which breed in the prairie regions of the northern United States and Canada and winter as far south as the coasts of South America. But each fall, black terns stop here on beaches such as here at Elmer's Isle, and in the spring they do the same thing on their return.
We've seen lots of birds here today. David, can you tell us some about what we've seen?
Well, we've seen brown pelicans, which of course are the Louisiana state bird, and a story that was quite a tragedy because of all of the pesticides that were poured into the Mississippi River system. Brown pelicans, as well as lots of other birds that depend on fish, were in serious trouble because of the buildup of pesticides and the failure of their eggs when they tried to reproduce. So the Louisiana state bird, the brown pelican, actually died out in Louisiana. But birds were brought in from Florida, and now, as you can see out here, there's a thriving population with many, many thousands of nesting brown pelicans in Louisiana. We've seen the same recovery nationwide of other fish-eating birds, from double-crested cormorants to white pelicans to bald eagles to ospreys, and all because of regulation of harmful pesticides in the environment. Other birds we've seen out here today, there's a flock of red knots. This is another long-distance migrant, some of the longest distant migrants on the planet. They breed in the high Arctic on the tundra and winter in southern South America, in Argentina, and fly twice a year, in the spring north and in the fall to the south. And these beaches on the Gulf Coast as well as on the Atlantic coast are vital habitat for them during that migratory period. They have to consume a lot of food in order to make that journey of many thousands of miles. We've also looked at some of the other smaller plovers. There are Wilson's plovers here, which actually breed on the barrier islands and on the barrier beaches, such as here at Elmer's Island. There are semi-palmated plovers, which again are migrants from the Arctic, and many of them winter here, spend the entire winter here. So we're seeing a very good cross-section of the types of birds that we found here. We saw some magnificent frigate birds. This is a species that is mostly confined to the tropics and is a pelagic species. It means it spends most of its life at sea, but many, many thousands of them spend the summer here along the Louisiana coast in the Barataria-Terrebonne and other estuaries in Louisiana. They don't breed here, but this is a very important place for them to feed during the summer months.
David, I can imagine that birds flying all the way from Central and South America are pretty exhausted by the time they get here. I understand even tiny hummingbirds make this journey. What do they find when they get here to our barrier islands?
Well, that's a very important question. It is especially important for those birds that have specific habitat requirements. And of course, any forest bird flying across the Gulf of Mexico, it's 450 miles until you reach the Yucatan. So when they reach the coast here in Louisiana, it's very important that they're able to find forest habitat and food. And very often, if they've had a struggle, if they've come across under adverse weather conditions, they don't have the strength to continue inland to the vast forests that are beyond the coastal zone. And so just narrow strips of coastal forests, such as our cheniers, as you can see behind us here, become critically important for those migrants. And unfortunately, these coastal areas are prime development sites, and much of the forest habitat that used to grow on barrier islands and coastal cheniers has disappeared.
What is the word chenier that you're using?
A chenier is an old French word used by the first French inhabitants of Louisiana to describe a place of oaks. Chêne is the French for oak. And in the marshes and open bays of South Louisiana, there are actually very few trees, but wherever there's a little bit of high ground, live oaks will grow, and the French called those places cheniers. And very often that's an old beech ridge or something that's now stranded in the marsh because of changes in the way the Mississippi River deposits sediments along the Gulf Coast.
And we have a chenier forest very close to here, do we not, on Grand Isle?
That's right. There's a little bit of chenier forest left on Grand Isle. Even though Grand Isle is very highly developed, there's several tracts of important chenier forest, and there's been a very strong effort in the last several years to preserve what's left of those woodlands, and they're very, very important woodlands, and we've had a lot of success, and that success has translated into convincing private landowners to plant trees and to enhance chenier habitat all along the coast, and the estuary program has been very involved in that.
Thank you, David. One more vital resource we have here is oil, black gold. We can see evidence of that by looking out into the Gulf here at the tremendous number of offshore oil rigs. Carrie, can you tell us a little bit about how important oil is to not only our local economy, but also to that of the nation.
Sure, sure. Actually, in the Barataria-Terrebonne system, the oil that is produced here makes up about 20% of the nation's domestic oil supply. So not only are these wetlands important because of what they produce and what they protect as far as our communities, but beneath them we actually harvest much of the nation's energy supply. What we're looking at here off in the distance are what we call our offshore oil platforms, and they are platforms. They're virtually cities. Okay, Gary, we've been watching our kids, our coastal route kids, planting mangrove. Now, the mangrove they're planting is black mangrove. Now, that is the mangrove that we have in Louisiana. Now, if we look down here, we can see some structures here. And now these little tubes here, these are the pneumatophores that are come up from the mangrove.
A little similar, almost look like cypress knees or something like that. These are parts of the root structure of the black mangrove, and they do two things that I can think of ecologically. One is, they're helping the mangrove plant. The other thing is that this is one of the ways that the black mangrove helps to hold on to sand. So these are, they help protect from erosion. And well, the other thing that they do similar to Spartina is they help to make a nursery ground, because whenever the tide comes up, little animals can hide in this region here, and it's very important. In the same way that Spartina hides larvae and small fish, these black mangrove pneumatophores work as a nursery ground and cover for smaller animals.
Great.
This beautiful estuary is also enormously fragile. Barrier islands, as we know, don't stay in one place, but they shift over time due to the Gulf of Mexico out here and the enormous forces that we find during a hurricane. That water and the wind that whips it up has the ability to cut right through the island and create this kind of a continuation all the way to the back lagoon here that you see in high tide now. Over time, this island has been rolling back and rolling back and rolling back as the sand gets redeposited. It's also moving eastward. Carrie, I understand that you are a descendant of the infamous pirate Jean Lafitte. Why would he have enjoyed a place like this? What was the attraction of this area for him?
We prefer to refer to Lafitte as a cargo acquisition coordinator.
Excuse me.
But actually, yes, he frequented this area. This was a very great area for him, very valuable. It was indeed a treasure because he was able to evade the people who were pursuing him. And also, he was able to catch food for his band of Baratarians and his crews.
So he found the tremendous resources here of shrimp and crabs and oysters equally as important as we do today.
Absolutely, and people are still looking for the treasure. We think the treasure is apparent wherever we look. It's always been here.
We'd like to share with you one of the treasures of the Barataria-Terrebonne National Estuary now, and that is our oysters. We have lots of them here, the biggest and tastiest ones on the whole planet. With us today is Dr. Earl Melanson from Nicholls State University to talk about oysters. Dr. Earl, I understand that oyster habitat is a big consideration when planning any kind of a coastal restoration project. Why is that?
Well, that's because oysters become very critical habitat for many animals in the estuaries. It's also an animal that never moves once it sets on the bottom, and too much fresh water can kill that oyster. Too little fresh water can bring in many predators. So it's to find that balance between fresh water and salt water, and to do that in a management way that we can also save our wetlands and perhaps preserve as much of our fisheries as we can.
Okay, who do you have with you here today?
Well, I have with me, you met her once before, but we didn't really introduce her. This is Alyssa Traig. She's in 4th grade at Vacherie Elementary. which is on the Mississippi River. And we're going to do some oyster work here together.
All right.
Alyssa, first thing I want to ask you is pick this oyster up and hit it with a hand, hit it with that knife. Hard or soft?
Hard.
Hard. What about the animal itself, the animal that's inside that? Do you think it's hard or soft?
Hard.
Think it's hard? Let's find out. I'm going to go ahead and shuck this oyster. And as I shuck this oyster, I'm going to go ahead and look at its insides. Okay? Now I'm going to take this oyster out. Okay? I'm going to take the oyster out of its shell, and I want you to hold it. Now I want you to tell me, is that hard or soft?
Soft.
It's soft. Kind of like what? What does it feel like?
Warm jello.
Warm jello. So here we have a very soft-bodied animal inside a hard shell. So that hard shell protects it, doesn't it?
Yes.
Okay. What about the color?
It's brown.
It's brown. But I want you to look at the inside of the shell. What does the inside of the shell look like?
White.
It's white. So we have a difference in color, don't we?
Yes.
And when you have a brown outside of the shell, that's an indication how productive our environment is, because we have a lot of different animals and plants that will settle on that oyster and use that as a home. So the oyster not only makes its own home, it becomes a home to a lot of other critters. And when you look at the inside of the shell, that's because of a chemical substance that's the same as our bones. What is that substance? Do you know?
Calcium.
Calcium. So this animal has taken calcium from the water and from the animals it's eaten and the food it's eaten to make it into a shell, just like we take food to make it into our bones. That's quite fascinating, isn't it?
Yes, it is.
And if we talk about oysters and we talk about habitat or place, let's take a look. What kind of critters can you see on these oysters here?
Barnacles.
Okay.
Algae.
I see a little green there where there's some algae.
I
see those little holes. You know what those little holes are for? It's actually for small little marine worms that can get inside the shell and doesn't hurt the oyster, but it becomes more a home. And oh, look what fell off. What's that?
Mud crabs.
Some little crabs. So we have crabs, we have barnacles, we have worms, we've got algae growing, which is a plant, all of that on this shell, which is telling you what kind of habitat we have. Now, let me also tell you that when we were out there collecting yesterday, do you know how we collected these oysters?
No, I don't.
We collected them with this oyster dredge right here. This is a 2-foot wide oyster dredge. The commercial dredges are anywhere from 4 to 5 feet in width. So this is just about half size. And you see these little rakes like? And that's what picks up the oysters. So we literally just yesterday went out just a couple of miles from here and dragged that along the bottom of an oyster reef, on top of an oyster reef, and picked up these oysters and brought them back for today. So we used that oyster dredge right there. While we were out there, there was a fisherman on the reef, and he was fishing. And I've got something I want to show you. I know you know this animal.
What do you think about all this, Alyssa?
This is very cool.
Cool. I know you know this animal because it's very common in our estuaries. What is this?
It's a redfish.
It's a redfish. And why do you know it's a redfish?
Because of its red tint and black spot on its tail.
All right. All right. So you
does
see
it
the
have another name, Alyssa?
Red drum.
Yes.
Red drum. So down here we say redfish, but if you would go anywhere else in the world, it's also called a red drum as well. So you can see that very distinctive spot, and you can see the color pattern. Let me ask you, do you think the color is in the flesh of the animal, the skin, or in the scales?
In the skin.
In the skin. Yeah, because if you take, and we don't want to hurt this animal because it's alive, and we're going to release it back in the water in just a little while. But if you would take the scale and just pick one of the scales up, you would see that it's almost clear, so that we can see the color underneath. And that color is no different from us having color in our skin. It's done the same chemical way, okay? I want you to look at this animal. I want you to tell me something about the mouth. Is it a mouth that's more up, pointed out, or more towards the bottom?
More towards the bottom.
So why do you think that's important for a fish like this?
Because it eats off the bottom of the water.
It eats off the bottom of the water. So what do you think it's eating?
Crabs and other animals that live on the oysters.
Crabs and oh, there you go. We're looking at crabs and other little fish and barnacles maybe that live on the oyster. So this animal right here is also eating on this. Do you think this animal can eat the oyster itself?
No.
Probably not, because the shell's too thick and hard, huh? but you have an animal that can eat the other little critters. So if you have this animal eating on all of those other little animals, we have a name for that. What do you call that? Is that a food chain or a food web?
Food chain.
A food chain. So we're showing a food chain here.
30 seconds.
Okay, so we have a great opportunity to look at this. Now, one last thing, we took that oyster and we did open it up. Now, I don't know where the other half, I'll use this half of a shell here. That's okay. If it opens like this, why does it open like that, you think?
So the oyster can get food and oxygen from the water.
That's right. So you have an opportunity here for an animal that is also getting food, and it has to open.
Okay.
So,
thank you so much, Dr. Malasaw and Alyssa.
thank you, Alyssa.
Now we're going to go to some questions. We have lots of questions coming in here, and what we're going to do is answer every single one of them, but not all on the air. The ones we don't get to answer, we're going to post up on our website, and we'll have the answers up there for you too. We'll also email you. So first question is for Mr. Carey, and this comes in from a classroom, Mrs. Paulino's classroom in Cuba, W.T. Sampson Elementary. Who came up with the name estuary?
Well, who exactly might have come up with it, I'm not sure.
Why did they name a salt and freshwater place an estuary?
Well, the word estuary actually comes from a word pronounced aestus. It's spelled A-E-S-T-U-S. And the word itself means boiling or agitation. So, you know, if you have a massive river or a river that's mixing with the ocean, you would expect it to be boiling and really, you know, vibrant and agitation. So that's where the word comes from.
Yes, you can see that, can't you? When you're out, you can see the Mississippi, the line between the big muddy Mississippi River
Absolutely.
and the ocean, and where it's
Absolutely.
mixing. It's
and
pretty
all the
incredible.
tides and the winds, and it's a place of a lot of energy.
Yes, yes, and change, constant change.
Yes.
All right. Next question is from Environmental Science, Bastrop High School. Does pollution have any effect on the Gulf of Mexico's dead zone? How is it being controlled? Very good question.
That is a very good question, and this really ties into what we've been talking about. We talked about the Mississippi River and what a huge watershed it is. Now, if you look at that, all the little rivers and streams that make up that watershed, and all those streams flowing into the Mississippi River, look like roots, and they pick up actually anything that's coming in and flowing in off the land. And as far as the Mississippi River, what it's picking up is a lot of nutrients or fertilizer. And of course, plants or grow well under fertilized conditions. So all of this fertilizer that's up in the Midwest and used in cornfields and sewage discharges, all these things that provide nutrients flow down Mississippi River. They go out in the Gulf of Mexico, and that's what's causing our dead zone.
Okay. The next class is from Mrs. Paulino's class in Cuba. How does a huge storm affect the 350 species of birds that are in our area?
Well,
Richard DeMay.
I don't think there's ever been an assessment to determine the number of birds that were killed as a result of a hurricane, but we imagine that there are thousands upon thousands of birds that are killed. I'll give you an analogy so that you could compare. Back a few years ago in the community of Grand Isle, they had a nice storm that came through, a sizable storm with a tornado. The following day, thousands of birds were counted along Grand Isle, Emerald's Island, and the Fouchon Beach. So that was just a small storm with an isolated tornado. You got to imagine that a huge hurricane would have devastating effect on thousands upon thousands of birds. And that would depend on the time of year that it would approach the Louisiana coast. If the storm came in June or July, it would probably do less impact to the number of birds as it might do in August or September, because a lot of the birds from Connecticut, Virginia, Michigan, Wisconsin, Quebec, and what have you that are coming through on fall migration end up here in September. So if we had a huge storm, probably thousands or hundreds of thousands of birds might lose their life as a result of that storm during that period of time.
Richard, tell us about a fallout, the concept of a fallout.
During spring migration, when the birds are coming back to North America and they're leaving the Yucatan, South and Central America, they typically leave at dusk and they approach the Louisiana shore some 550 miles away from the Yucatan Peninsula around midday. If they run into bad weather on the way, when they're flying across the Gulf and they run into a frontal system that might be approaching Louisiana or out into the Gulf, the birds are flying against the wind now, and that'll use up a lot of their energy and they become really exhausted very quickly. And what'll happen is when the first land that they end up seeing, they'll all just land and they'll light on the ground, they'll light in the trees. In fact, they're so exhausted that if you're walking around in the woodlands, you could actually kick them out of your way because they won't get out of your way. Or they'll land in the trees and they'll get real close by, and of course that makes a perfect opportunity for a lot of birders that are looking at these birds during that time.
They kind of look at you and say, don't mess with me, I just flew across the Gulf of Mexico. The next question we have is from Mr. Barry Guillot's class at Hearst Middle School. Hello, Barry. How many plants does the Coastal Roots program plant per year? And to answer that question, we have Rachel Summers from the Louisiana Sea Grant program. Rachel's been a big player in the Coastal Roots program.
All right, every year we've planted about 4,000 trees. The students have planted wax myrtle, bald cypress, black mangrove, and red mulberry trees across southern Louisiana to help replace damaged wetlands.
That's a pretty amazing story. For the next question, from Monroe School, 5th grade class, tell us a funny story about crabs. The answer to this is on our website. There is a story on our website, www.btnep.org, and the story is, why does the crab have no head? You can find that and 27 other activities related to this program if you go there. Now, we've been talking a lot about the land loss problem that we have. Let's just give you a few more details about why this is so important to us. You've seen how wonderfully productive this estuary is. We ship in seafood all over the country, all over the world. We have a very unique culture, as you saw by these French-speaking Cajun musicians. Wendell, come and tell us, give us a few more details about the land loss problem and what we stand to lose.
Well, you know, we sit in this area, and it's such a unique area. You know, the Mississippi River is the 3rd largest river in the world. It's built the 7th largest delta in the world. And the river built it, but when we moved into the area, I'm talking about people, Europeans moved here, we decided we didn't like flooding every few years, so the Mississippi River was blocked. In essence, this tremendous thousands of square miles of marshland, the biggest marshland continuous estuarine area in the nation, we basically gave it a heart attack because we stopped the flow of the nutrients, which is the waters and the sediments that build this land. Now, what we need to do, we need to continue having this flood protection, but we need to find ways to get the water and the nutrients there, and there are ways to do it. It's just going to cost us a lot of money, but we are working toward getting that done. And it's critical not only for the people down here, but also for the rest of the nation, for the things that this wetland area produces for the nation. It is America's wetlands because 41% of the United States is drained by this area. Every bit of soil that we're standing on comes from Indiana, Illinois, Iowa, Ohio, all the drainage basins. This used to be Gulf of Mexico 5,000 years ago.
And now it's America's wetland.
We live in the United States, but we live on the re-United States.
That's right. Carrie, what is the estuary program doing about this tremendous problem? We have just a little bit of time left.
Well, the estuary program is a partnership, and it's such a huge problem, takes a lot of partners, and that's what the estuary program is. It's a partnership, and we have 43 different groups that are part of our management conference, and that's our role. The estuary program brings these people together.
A lot of them you saw here today.
Yes.
All right, thank you so much for joining us today. Next time, we hope you can stay a little longer and help share the beautiful, wonderful treasures that we have here in South Louisiana.
Why don't we share some of those treasures?
On a passé dans tous les enquêtants. On a venu le même matin, le jour était presque assez. J'ai passé par la porte en arrière.